Okay, what I'm going to go through here is generally called the piecewise smooth parameterization of a curve. I'm going to pick a simple one. It's just going to be a triangle with vertices from 0, 0, 0, 1, and 1, 0. And so that's going to look like this. And I'm going to have it go counterclockwise. All right, the first thing to do is to set up your vector valued function just with t from 0 to 1, so kind of 3 separate functions. The first one, r1 of t, is just going to be tj from t from 0 to 1, and that'll move us up 1. R2 of t is only slightly more complicated. It's going to be ti plus 1 minus tj from 0 to 1, and that gets us a diagonal right here. Let's kind of think of it as 1 minus x is that diagonal. And then our third, r3 of t, is just going to be 1 minus ti, because at 0 that gives us 1, and then at 1 that gives us 0, and that moves us back that way. So the thing to do here is to use what's known as a time shift, and that will allow us to put it all together into one piecewise function. So the way I think about it is, for every second over I move, I start the interval at, I have to take away a second from the equation. This first one will remain the same since it works from 0 to 1. So let's just say r of t now, since it'll be one function, equals this big piecewise. So t of j from 0 to 1 is going to remain. And you see I have to leave the second less than sign open because it can't be defined twice at the same point. And so what I want next is I want to take this second function and shift it over. So what I'm going to need to do is I'm going to need to replace my t with t minus 1, and that will make this equal. And so I go t minus 1 I plus 1 minus t minus 1 is going to be 2 minus tj. And that will allow me to go from 1 to 2, and so it's smooth. It goes 0, 1, 1, 2. And then I need to do the same thing. Since I'm moving it 2 seconds, I need to subtract 2 seconds. It was 1 minus t, and so it's 1 minus t minus 2 now. And so that's going to be 3 minus ti for this, and that allows us to go from 2 to 3. And I can actually put the equal since this is the last one. And as you can see, that's going to go from 0 to 1j, so that still goes up. This is going to go from 1 minus 1i, so 0i, 2 minus 1j is 1, and so that goes from this point, and then add 1, and it goes down here. And then 3 minus 2 is 1, and then 3 minus 3 is 0, and that gets us back here. And that puts us all in one function, which is going to be really important when we're doing line integrals. And you can use this technique of the time shift no matter how complicated this is. If part of it was, you know, t plus t squared, ti plus t squared j, if you needed to shift it over 1 second, it would still be t minus 1 I plus t minus 1 squared j. And it ends up being exactly the same. You just replace this t variable with whatever the time shift you need in order to make it a single function. And I hope this has been useful. Just thinking of it this way has really helped me, and I'm sure it's going to come up to create smooth functions when we're dealing with Green's theorem and line integrals in general, as well as probably a question about smooth parameterization in the first place, since that was covered at the beginning of class.